Hi there. You want me to have the microphone, don't you? There we go. Start again. Take two. Hi. So my name is Preece. I'm from Cinch. I'm the infrastructure tech lead there, and I think that Cinch are in a relatively unique position, and that I've got something it's worth sharing with you. Hence, I feel qualified to stand up here and talk. So. It's going to be reasonably high level at first as I try to tell a story that you're probably all quite familiar with, but then I'm going to go into a few more technical details. In terms of the agenda, talk a little bit about myself, my background, Cinch, why I think there was something unique there, the team I work in, talk a little bit about cloud and DevOps, and then reference State of the DevOps report, talk about team topologies, and what we do, plus how we do it, which is pretty significant here. To start with, take you on this journey. My background is that I'm an infrastructure engineer, so I've worked at a number of organisations, public and private. I started as an infrastructure engineer, and moved into sort of more management roles, looking after large infrastructure estates, but effectively I spent a career building boxes, and then more recently I've moved into more AWS stuff. So Cinch, online marketplace for used cars, started up in 2020, so effectively born during a pandemic. When I started, there was no office. We have no VPN, we have no network, we have no servers, we have no containers. We have Office 365 for collaboration, so that's all in the cloud. Finance and HR systems, that's all provided from group head office. So the tech stack there, serverless, following all the AWS serverless model. It's a very strong DevOps culture. We've got about 20-25 dev teams. They all responsible for building and running the components. They're all autonomous teams. So in terms of the culture, it's DevOps, so it's fast flow, deploy straight to prod, use good observability to understand what's going on in the application. On one key thing which really helps is TypeScript is used throughout the whole Cinch technology. So at the front end, all static web pages, JavaScript, compile from TypeScript. Middle, so we've got lambdas, Node.js lambdas, compile from TypeScript, and infrastructure is all defined in CDK using TypeScript. So everyone across that uses that common language, which is really helpful. The infrastructure squad. So I was thinking when I started, why do these guys need an infrastructure person? Well, in the infrastructure squad, we've got 4 engineers, plus myself as a TL. We've got a product manager, and we've got a business analyst. So you're probably thinking, what do these guys do all day? I'm going to come back to that one. So, cloud usage. I know you know this story, we're an AWS user group, but let me just recap on that. So cloud, massive growth. PaaS, that's typically outpacing some of the growth we're seeing in cloud, AWS certainly. There is data privacy, information security are some of the largest impediments to growth. So I'll come back to information security in a minute. And I think these days, lift and shift is generally seen as a kind of a bad idea. Using the elasticity of the cloud is a good idea. I think we can all agree. There is still huge amounts of waste in cloud spends. If you look at the reports, the latest things, organizations report huge amounts of waste. So the last place I was at, not since, the place before, that was considered very well optimized. It had a large estate in AWS. We would talk to the account management team and they say, oh, you guys are really, really well cost optimized. but we spent a fortune, mainly because it was all ECS and RDS, and that stuff's expensive. It's pretty much the most expensive place you can find to run a server is in the cloud. Also, you've got a lot of cloud cost management solutions, things like Cloud Zero, Cloud Keeper, Cloudability. I don't know if you've looked at those solutions. They basically analyze your estate and then give you ways to optimize it. So they will typically guarantee you cost savings simply because most places are just not that well cost optimized. There's a lot of wastage. Serverless, big trend, big cinch. So it's great, isn't it? It's infinitely scalable, much lower cost. You only pay for what you're using. There's a relatively small amount of organizations using it, but it's seeing very large growth. And it's got massive advantages in terms of environmental. If you're not using that compute, then you're not burning through the carbon. Trying to provide it. We'll talk about that in a minute in terms of, the next speech in terms of environmental, but it's got massive advantages in security as well. I'm sure you know this, but take cinch, for example, because we don't have servers. There's no monthly patching. There's no sort of desired, complex desired state config. I remember in a lot of places I've worked, every time a particular vulnerability came out, a virus of some sort, it was don't wait until the second Tuesday of the month, whatever it is. You've got to get on, you've got to patch there and then. It just wasn't a thing. When Log4j came out in Cinch, just talk to the information security guys like, so what? Doesn't matter. We don't have server, we don't have to do all that patching. We talk about DevOps as well. Again, I know you know this story, but this is where, if I lay a bit of background, you can see where it's going to get interesting. Migration to DevOps practices. So in the old days, devs wrote the code, threw it over the wall to ops to implement it, to deploy it and manage it. I think we can all agree there was problems with this. Agile revolution, it required frequent incremental releases. This was achieved through automation with coding. There was a need for a feedback loop, so development teams own the code more, own that. And DevOps kind of brought both sides together. Cloud, that made it even easier, so you can spin up whole environments in the cloud using CICD. So that just makes DevOps even easier. So this is all good, right? So IaaS in the cloud, massive use of IaaS in the cloud. Anyone here ever had the responsibility of running a large estate of servers? A few, 100, 200, 500, 1,000, 2,000, 5,000? You beat me now. How many?
Chef installation configuration for 50,000.
50,000.
50,000 Windows, 100 in total.
That's a lot. I thought I was doing good, but I'll go home. So, yeah, the last place I was responsible for 4,400 servers at the highest point. So, how do you run 4,400 servers? Well, this is the previous organisation. The answer should be automation. You can't run that many servers without it. But where we were, honestly, how we ran it was badly. I mean, we knew automation was the answer, but on average, every server that comes in is a little bit more work. We were getting 4 or 5 requests a week. We had Puppet, we had Red Hat IPA, we had Windows SCCM, we had CF Engine, we had vRealize automation, we used CloudFormation, we had automated patching schedules, but we were kind of always behind the scenes, behind the curve on this. I'd go to talks like this where someone would be stood up telling me how they automated everything and how they worked in some kind of nirvana state and everything was great. And we tried to get there, but we were constantly just managing this massive estate, so you could never have the time to fully automate it. What you've got to do is you've got to put the automation in first, right? Once you get behind the scenes, you can't get your head above the water. Automate first, get all that stuff in. Okay, I'll come back to that in a minute. Also, we spent an awful lot of time, this is the last place, cost optimizing all those servers. We have 4,400, we had about 2,000 in AWS. So there's a lot of time spent cost optimizing that. Right sizing, shutting down non-production instances when they're not in use, buying RIs, buying savings plans, looking at the trusted advisor reports, following all the processes, everything you're supposed to do. It's very time consuming, it's very hard work. Networking as well, so using VPC peering, you end up with just a spaghetti junction of network connections. It's a bit of a nightmare. Use transit gateways, it makes it better, but it's still not easy. To me, you're effectively managing traditional infrastructure in the cloud. So at that last organization, what we did as well, whenever new stuff came along, that was always a cloud first if it was new stuff. So we would create an AWS account, we'd do some configuration, put the VPC in, maybe connect it back to the direct connect so it can talk back to on-prem. But we'd basically hand over the environment and then we'd throw it back over the wall to them. So I call that revenge. But I think that's quite common, right? I can see a few nods. So what we did, we set all that up, and those dev teams were then expected to manage and run their environments in AWS. So apparently this is not an uncommon problem. This doesn't happen at Cinch, but the point is devs have got to overcome all those the challenges of cloud. And you think about all the security. Organizations are concerned about the security aspects of cloud, but you're putting all this extra stuff on developers to think about that. In that last place, if they had a problem, and they can log a service desk ticket, and we were the cloud team within the infrastructure department, they could log a service desk ticket, and we would look at that, and they would maybe get a response about a week later, if they were lucky. We were busy cost optimizing stuff. But I think about a dev team using serverless. So what kind of things have they got to think about? Deploying Lambda, DynamoDB. There's no, at Cinch, there's no DBAs anymore. Everything is just down to the individual team to manage this, autonomous. They've got everything they need, but they've got to think about, Lambda, DynamoDB, API Gateway, CloudFront, all the IAM roles and policies. And people don't like working with IAM roles and policies on the whole, is what I've noticed. I do, but developers, it's less popular. But they've also got to think about the application architecture, their CICD pipelines, observability tool to see what's going on in the environment, and then they've got to think about the security restrictions. The last place, we'd put service control policies, we'd have permissions on IAM roles for stopping them deploying. So it was quite hard, and they needed help. What that causes is high cognitive load on those teams. So it's just too much to think about. High cognitive load causes more burnout. This is not going to facilitate fast flow, which is some DevOps world, that's what we're all looking to achieve. Just talk about state of DevOps as well. So I'm referring to, in preparation for this, went through Puppet's report of 2021 and a couple of key points from that report. So almost everyone is using the cloud these days, but most people are using it poorly. Organizations also need to address organizational and team aspects. While cloud and automation are important, this is the things that often hold them back to achieving high levels of DevOps maturity. They need to clarify their mission, their primary customers, interfaces, what makes for healthy interactions with others. Other comments from the report. Enterprises are held back from evolving to the highest levels of DevOps maturity by organizational structures and dynamics. You can tell it's American. Highly evolved firms use a combination of streamlined teams and platform teams as the most effective way to manage team and cognitive load at scale. they typically have, like high-level firms, they typically have a small number of team types whose roles and responsibilities are clearly understood by themselves and the teams they connect with. It also says the use of platform teams are a key to success at scale. Platform teams. This is where we come into it. I do have a use at Cinch. Highly evolved organizations tend to follow the team topologies model. Are many people aware of what team topologies is? 1, 2 hands, 3 hands, 4, getting a few more now. Not lots of people. That's good because I've got a slide on it. If everyone had said yes, I don't know what I'd have done. Anyway, so it's a book by Matthew Skelton and Manuel Pace, and it's one of the few key publications which really influences engineering culture at Cinch. What it talks about is this book. It recommends orgs reduce down to just using 4 team types. This is easy to understand from people in those teams, but when you're trying to understand what other teams do and the functions of it, it's easier for them to understand. Organizations are complex and it's hard to understand what's going on. This helps. So it talks about 4 fundamental team topologies. Streamlined, which is aligned to a flow of work, usually from a segment of the business domain. Enabling, which help streamline teams to overcome obstacles or fulfill missing capabilities. Complicated subsystem teams provide some kind of special expertise so they can take a little bit of the work away from streamlined teams, reducing the cognitive load. And platform teams. So they will provide an internal product to accelerate the delivery of streamlined teams. Now, the book says this is not the only way to do this, but research shows that this will fit with most organizations. It talks a lot about reducing interactions between teams rather than traditionally, a lot of places I've worked was all about communication, communicate here, communicate there, but that's hard work, people realize. Reduce those interactions. You don't always need them. Reduce it to a small number, but improve the quality of the interactions. Reduce cognitive load. Don't resolve dependencies. Eliminate them. So one of the ways we can do that is platform team, provide everything as a service. So people aren't making multiple requests, waiting for someone to do something. Provide it, think API, provide that so they can just interact, they can get what they need. They're not making human requests and waiting for things to happen. And provide an independent developer platform for those streamlined teams to build on. That's what the platform team does. So state of DevOps, again, it says the majority of those towards the higher end of the DevOps maturity curve are using self-service platforms with the minimal use towards the lower end of that maturity curve. So I want to talk about our platform. I feel like I've set the scene, explained how we got here. I want to talk a little bit about how we're solving this problem. I think we're doing things a bit differently, so I think I've got something to shout about. What we're not doing is throwing that cloud environment back over the wall. We're refining it. We're trying to use a product-led approach. So we develop a product, we provide it to customers, we know who our customers are, we know who are using it, and we seek feedback from them, and we build that feedback into our roadmap, things that we're doing. We try to provide everything as a service to minimize dependencies on us. We like talking to people, we like talking to those dev squads, but we don't want them to need to talk to us. They should be able to do stuff, work on what we've done without needing us to be there. In theory, we should all be able to go on holiday all at the same time. In practice, that's not allowed. We do also provide continuous help. So some of it is using that enabling team model. So we're helping those dev teams to do things because they get stuck on permissions, all sorts of things. Some of the principles in this team, we provide a golden path, not a golden cage. We don't restrict them. It's a self-autonomous team, so we give them a lot of freedom. Although we do have, we aim to make the right choice easier, although we do have some restrictions. InfoSec reasons, we've kind of got to limit certain things. We never want to be a blocker. because people aren't constantly dependent on us, the idea is if they do need us for something, we will help. If they've got an inability to deploy something, we'll consider that like a P1, priority 1 issue. So an AWS account at Cinch. So we provide lots and lots of these accounts to lots of different teams. How does that work? So we stack these accounts with a number of different things like IAM resources. So who knows what permission boundary is? Who likes working with permission boundaries? That's a none. Permission boundary, for those who don't know it, it's a restrictive policy, effectively. It specifies that you might be able to do all these things, but you can't do this, this, and that. So what you can do is you can apply this to an IAM, a user or a role, and if you were to create a new role and you were to give it admin, but it has this permission boundary attached to it, then it doesn't really get admin, it only gets the things that you've really allowed in the permission boundary. So that's the maximum, that's the boundary of permissions. They're not pleasant to work with, but infrastructure squad, we work with them all the time, so we can help other people doing that. So we deploy the permission boundaries into there. We also create deployment mechanisms, so people would, squads would deploy from GitHub Actions. So we've got roles in there that can be assumed from GitHub using OpenID Connect. So we don't have IAM users. You can't create an IAM user in a Cinch AWS account. It's blocked because we don't want IAM users. You have that problem of long-lived keys, and most people who have worked with AWS have seen, yeah, you've always got loads of long-lived keys, and people should rotate them, and they know they should, but they don't. We deploy a hosted zone for each account. So every account has a default hosted zone. That's live, so that's delegated from another higher level zone, which is managed by us, infrastructure squad. We deploy certificates into the account. There'll be a certificate that relates to the hosted zone, but there'll be another couple of other certificates. We don't allow other certificates to be created because all the certificates you'll ever need should be there. We create an event bridge. Event-driven architecture. So in Event Bridge, every account has a default event bridge. It's pretty easy. Cinch, the app uses event-driven architecture, but if you want to start doing event-driven architecture across accounts, it takes a simple thing and makes it really complicated. So what you then forced to do is effectively create like a master and a replica. Write to the master replicates, and then read from the replica. So it means you can use loads of accounts, all using event-driven architecture, passing messages across each other, but you've got that structure in place. It's complex. We provided it, we've explained it, we've set the rules on it. It's easier for dev teams to use that, and we've set the permissions up so they can use it as well. So we do all that for them. We've got backups in there, dev teams. Ideally, they would make sure their stuff's backed up, but we've got things in there that will back it up no matter what, even if they don't. So we've got that covered. VPCs. Talked about the mess you can get into with VPC peering, with transit gateways, but we've made it really simple. Because we're relatively new and we got to design some of this from scratch, we've got one VPC in a dev account, one VPC in a prod account, and we just share that to all the prod accounts and all the dev accounts. It's just one VPC, or three private subnets, 3 public, and they're just shared out. So no one has to create VPCs. They can just reference it. It just makes it so much easier. And if you want to, you can communicate. You've got security groups, but it makes it so much easier. And again, dev teams don't have to worry about that. Web ACLs, they're creators, they can just reference them and use them. We bootstrap every account with CDK. Who works with CDK? Who knows what it is? Some people, a lot of them from Cinch. If you do use CDK, just beware, review the CloudFormation execution policy. It will surprise you, it's admin, it's a nightmare. It's very good, CDK, but you've got to secure it. Anyway, that's a separate thing. So we deploy logging resources. We have a log archive account. Any logs within AWS get sent to the log archive account. So you've got it in a separate place. So you've got this non-repudiation of logs. Information security people love that. We use Datadog. Datadog is integrated with every account. When an account's set up, Datadog is just integrated with it, so those logs will ship to Datadog, no problem. No one has to think about that. Just there's other things they can do, but the basics are all there. We use Security Hub. Does anyone use Security Hub? Couple of people, couple of hands. Security Hub is kind of funny. So it monitors the security of an AWS account and has all sorts of checks that it can do and report on the security status. You go and create a brand new AWS account and you look at the security status, they give you out of 100%, new one, it gets about 40%. This is straight out of the box. AWS give you it and then they say they'll score their own stuff and they give them themselves 40%. Because it's kind of, as an example, if you use IAM users, you should have a password policy in IAM users, and you start it really basic. Security mandates, you should have a particularly strict password policy. So straight out of the box, it fails. It's kind of weird. So there's a lot of noise in Security Hub as well. It monitors all sorts of stuff. For what we've done, we've gone through every single account and we've disabled all the controls that we don't care about. We've enabled the ones we do. And so when you get a cinch account, so Security Hub rating is 100%. Everything's fine in it until you start doing stuff. And then if you do stuff that doesn't follow good security practice, you can look in Security Hub and it'll tell you. Particular things, particularly bad things we blocked. But if we think, well, you shouldn't do that, there might be exceptions, then we'll give a way to report on it. Golden path, not golden cage. I got lost with the Security Hub stuff. So other products, we provide data, we provide GitHub accounts, so we kind of manage GitHub, Datadog as well, and we got some authentication systems back to Azure AD. So we make a bit of use of that. So other products, but they're a bit less developed, and I'm here to talk about AWS anyway. So how do we do this? Software engineering. So I was an infrastructure person. I now spend most of my time looking at VS Code, following software engineering principles, processes. I know everyone's been doing that for a while, and everything's been moving to software, but I think what we're doing, we've taken it up a notch, which is why I want to tell you about it. That's why I think it's worth me standing here explaining all this. So we create these accounts from an infrastructure perspective, but everything, like what do we do? What are these software engineering techniques we're using? So everything's infrastructure as code. Yeah, that's normal. People are doing that for a while. Everything's pipeline deployed. So just down to a DNS record, that's infrastructure as code, deployed via a pipeline. Every certificate, every secret, every parameter value, it's all in, it's defined in code and deployed via pipelines. We use CDK. We use TypeScript, but we're using object-oriented programming techniques, classes, inheritance, we're using loops, different constructs. This, to me, it was a big deal moving into like software engineering, but all that stuff is not that hard. Like, I'm not even that good of a software engineer, to be honest with you, but it's okay because some of the team are. But some of the basic stuff, it's not that hard. Pipelines, so we use AWS Code Pipeline. We also use GitHub Actions. We write everything we do. We write unit tests. It is kind of difficult in CDK because you're not assessing logic that you might do in an application. But we have tests set up. Every repo that we use, every Git repo, we have coverage rules to make sure lines of code are covered by tests. So we do that. Everything we do is a PR, a pull request. We constantly interact, talking about pull requests. That's how we manage our work. And we use pair programming. So we work together in pairs, working on something, people watching it, and keep alternating. So when you do come to write that code, you then don't have to wait for a code review because someone's been reviewing it as you go. So reviews are instant. You can click merge, and deploy it. Goes off, the pipeline deploys it, and everything's fast like that. So we use trunk-based development. Our main branch, that defines what is in prod at any one point. We protect our main branch. Like I said, we've got the unit tests. Every time we deploy, every time we push anything to the main branch, it goes through all our tests. It checks things and it makes sure everything is good. So we do not break the build. Whatever's in that main branch is a definition of what's in production. We publish packages to NPM, so that is in JavaScript. There's a public library of packages, TypeScript, JavaScript. So we publish packages into that, and we publish them private, so it can only be seen by us and Cinch. But we use those modules and import them into other pieces of software. So we have a module for all the accounts in Cinch, and then we can pull it in, so we have a loop through all those accounts. So we're using proper software engineering techniques there. We use Renovate Bot, so that is a thing that if you've got one package, one project, and it has dependencies on these other projects, if those other projects change, Renovate will notice that, and it'll update that. So we'll automatically merge things depending on the type of change that's been done. So if we add a new account, and we've got all these accounts that do things to every account, it'll just automatically get deployed. We use a lot of AWS tools as well. We use AWS organizations, extensive use of that. We use a lot of service control policies that, if you don't know, that's just it's like a top level permission that says what you can and can't do. It's typically used to put blocks in, but you can get more complex ones. We use a lot of that. We grant resources based on an OU, so that's like a folder. AWS organizations, you might have an organization structure, departments, teams, and you can put accounts into there depending on the folders that you're in. You can apply certain things to them, and we teach other software engineers in Cinch to use that when they want to share things between accounts. A lot of it, we use stack sets. It's an AWS CloudFormation stack that goes across multiple regions or multiple accounts. We use control towers, which is AWS's recommended way of managing multiple accounts. You can set them all up with consistency. And we use things like CloudFormation custom resources, which honestly they're painful, but what it is, it defines a thing where you define it in CloudFormation, and ultimately what it'll do, it'll call a Lambda script, and that Lambda script will do something, and then you're writing something in Lambda. So we're typically writing API calls. This is how we do, I think this is one of the ways in which we manage Security Hub. So we'll it'll click off a Lambda using AWS SDK to talk to the endpoint for Security Hub and write certain things and configure it that way. So it's software engineering. This really helps us appreciate our customers. Our customers are software engineers. We're doing what they're doing. We get hit by the same issues that they get hit by. We experience the same pains. We're using AWS accounts to do things as well, so we're using the same permission sets. I think the term is we eat our own dog food. I like that slide. We use a lot of observability as well. So we use Datadog dashboards to see what's going on in the accounts. We watch our pipelines. We never leave a pipeline in a failed state. We monitor our stacks for stack drift. If a stack has drifted, we investigate what's going on. This is the CloudFormation stack, defines the resources. The resources aren't as we defined. Why? Let's investigate that. Usage of accounts. So AWS recommend not staying all your stuff in one account, spread it across between accounts. So we monitor, there's a project to migrate some workloads between accounts. If we monitor that, what's going on in each account, how much workload's in there, see that progress. We did a DNS migration a while back, took a main hosted zone from one account to the other. You could see in Datadog all the requests coming in and how they went from that account to that account. So we use a lot of that. OIDC roles, so we don't use IAM users anymore. We use OIDC role, which is a role that can get assumed from a GitHub action, a runner. So when we were migrating, we watched, are people still using those? Who's still using the old IAM users? And we can see this. We've got good observability of our, call it our infrastructure, but it's kind of a software app. We watch the service limits, although we watch the service limits, and there's more things that we can do with that, which is why I put a star, because anyone at Cinch will know that does cause issues at times. it wouldn't be that difficult for us to use that observability to monitor what's going on, look for certain errors, and display it in stand-ups every morning and see, oh, I can see these people are deploying there and they're getting this error, which is they've got that a lot. So we can figure out through the pull request, who's merged that, we can see who they are. We don't know this yet, but maybe a next step is in the morning we can ring them up. I understand you can't deploy. What's going on? Have you tried this? You're probably hitting that. That's a world away from the last place I was talking about, where they'd log a ticket and we get back to them a week later. Another thing, so we don't really use a lot of ITIL. It's kind of a dirty word now. Everything we do is through pull requests, which is, I guess, I'm used to screwing things up working in infrastructure. Simple changes that go horribly wrong, network device upgrade, cause an entire site to go offline, done that. VMware, make a mistake on a host and you've got 50 servers offline. Yeah, they'll boot up somewhere else, but still it doesn't go down that well. But these kind of things, they go with the territory. I've not caused a single major instance and been working at Cinch 18 months, which is nice. Like I said, all changes go through a PR. PRs, all branches have a name that references a JIRA ticket. That's how we manage our work. So, and then when we're making changes, we're using commit messages. And every message, we use particular terminology in our commit messages. So you can see everything that's been done has been done with the audit trail, and everything's deployed into production through pipelines. So you've got this easy, like this perfect audit trail and this easy this rollback. So if you ever work with ITIL, sort of service delivery people, they will kind of bang on about this, how you need to have this this audit trail. But we've got that, we've got it perfect. We don't have any change control board. I used to hate going to CAB. There'd be a load of people who didn't really know what I was doing that told me that I couldn't do it because they didn't understand it. But we don't have that. We just don't need it. Like I said, we've got perfect config management database because everything's defined in code. We've got extremely low, almost zero change failure rates. So look, in summary, I explained this, I explained what I did at the beginning because I think serverless, teams working on serverless is going to be more common. People are using the cloud more. There's going to be much more focus on waste, what's going on in the economy. People are going to want to save some of the wastage that's going on in the cloud. So this has come in. Serverless is growing. There's a general uplift in DevOps processes. We're seeing that anyway. But what hopefully I've explained is here's a way to do it using platforms. If you're an infrastructure person or you're an ops type person, this is where I think things are going. And if you're a dev, this is the kind of thing you can expect. And that was me.